Hi, this is Paul again. I've got another video to show you, and I'm calling this the amazing CubicWonder Semi Dirac. In this video, I've got something real interesting to show you. So I think I'm going to start this by showing you the basics of CubicWonder first. Now, for those that are unfamiliar with CubicWonder, we'll start with the Chico and Chica cubes going together. Now, both the Plato cube and the Bucky cube contains 4 Chico and 4 Chica cubes, and each Chico and Chica cubes contain 5 pieces, and they can be solid pieces. Now, a very important feature of these cubes is that they can be sliced, as shown. Now, the Plato cube can slice into 3 separate 1/3, 1/3, 1/3 section. Now, the Bucky cube is a little bit different. This slices at the midsection, and then we have a 2/3 and 1/3 gaps, the top and the bottom section. Now, the Bucky cube splits in the center, and it provides a hexagon, and this can be used for carbon fiber, but you can see that in my other videos. Now, in this video, I'm going to focus on the Dirac slope geometry. So let's make a start. Now, in front I'm showing you a Bucky cube and 2 Plato cubes. Now you can see how perfectly the 3D geometry is perfectly relating in symmetry to each other. Now I'm showing the Bucky cube in the center, and you see the cube outline for 8 cubes. Now, the cubes that surround the Bucky cube are called Plato cubes. We can call the Bucky in the center and 8 Plato cubes a type 1 surrounding. Now, in front I'm showing you 4 examples of different Bucky and Plato cube arrangements. There could be more, but these are just an example. And in front I'm showing you the type 1 going together, the 8 cubes going together and 8 cubes reversing. I'm going to rotate these 4 types of cubes around the x-axis for you to take a look at them. Now, what I'm showing here are just 4 different examples. I did show type 2 in a pyramid assembly in a document I showed on SlideShare. In this video, I'm going to just show you type 1. Okay, now I'm going to show you what's so special about Dirac. It's a sloping geometry. Now, this was discovered by a physicist named Paul Dirac from Bristol, UK. Now, he obviously discovered this by looking at equations. So I'm very impressed that Paul Dirac could see this using algebra and stuff. Now I'm showing how the Bucky cube can be sliced at 1/3 and 2/3. So now I'm going to add the Plato cubes, and I'm going to do the slicing on them for you to see what's happening. Now, what's amazing about this slicing, notice that the slicing on the Plato aligns to the slicing on the Bucky, yet the Bucky is 1/3 and 2/3. Isn't it amazing? I can't see how university professors could ignore this wonderful order for 15 years. I guess they have their reasons. Now I'm going to show you something new. Now, in front I'm showing you a string of 9 Bucky cubes, and notice that they are going from long diagonal to long diagonal, and you can see they're forming a cubic shape of 8 Plato cubes and 1 in the center. I'll give you a closer look at it, and I'll spin it around a little bit. Now it's plain to see that the Bucky cubes connect by the corners, the long diagonals to the corners. So this is what gives it the slope. Okay, let's go back to the 9 Bucky in a slope. In this video, I'm going to link the Plato cubes to the Bucky cubes as a parent. Now I'm going to run the same animation and you can see the Bucky cubes forming a cube. Isn't that something? And now I'm going to rotate the cube as well. Now if you look at this finished cube, it shows 64 Plato cubes. Now this animation showed that 9 Bucky cubes produce 64 Plato cubes. Now this isn't correct. After a bit of research, I realized the problem. It's a center Bucky cube that's the problem. It's not 8 to 1. So I guess we have to subtract the center cube. Okay, taking a string, making a string into a cube, I've decided to see if I can put the periodic table together. Now this has been quite a task, but I think I've achieved it. So let's take a look at it. I am working with the sloping strings to accomplish this, so I'm not producing a pyramid in a vertical orientation. I'm sorry about that. So to solve that, the finished pyramid, I'm straightening it out into the vertical orientation. And now I can give it a spin around and you can see it better. And as you can see, as it's spinning around, I'm showing a Bucky cube and I'm showing an innate Plato cube outline. Now if I showed the Plato cubes, you wouldn't be able to see the Bucky cube, which is the perfect center of the 8 Plato cubes. Now I'm going to show you the same animation, but I'm going to change the cube outlines to 8 Plato cubes in each of them outlines. So now I'm going to show a rotation of the Plato periodic pyramid. Now this setup is exactly the same as the Bucky cubes, because the Bucky cubes, you look at the outlines and there's 1 Bucky in the center of 8 Plato cubes. Okay, now I'm going to show you the Plato pyramid and the Bucky pyramid both together so that we can compare everything. Okay, if you look in front, I'm showing the 7 periodic of 1, 4, 4, 9, 9, 16, 16, and it comes to 59. Now you got Plato and Bucky cubes, so you get 59 and 59 equals 118 elements. I think I'm going to call it a day now. So this is Paul saying thank you very much to the people that think order is a lot better than two-dimensional chaos.